Good afternoon, students. Here, in this part of this video, I will explain about a planetary gear system or epicyclic gear train. Epicyclic gear train. Okay. So first of all, you observe this diagram. Here, this is the diagram we have. Uh, with this diagram, I can explain the planetary gear system. Simplified view of planetary gear system or planetary gear system. Okay, this is simplified view. uh, that is the figure A is the simplified view and actual planetary gear system, which is figure B. Okay, you may observe here simplified view of planetary gear system. This is the simplified view of planetary gear system, and simplified view of planetary gear system. And here, so first I will show you different parts of planetary gear system in simplified view. This is the simplified view here. So this circle whatever you are having, that is also known as sun gear, and these are the planet pinion gears. These are the pinion gears, and planet carrier or a planet case. This whatever triangle you are having here, this is the planet carrier or case, and this ring, outer ring, whatever it is there here in this diagram, is the ring gear. Okay, so, and actual diagram of planetary gear system you are having, this one is the actual planetary gear system. Whatever you are having, similarly, um, here this one is the sun gear. So previous, in the previous diagram also I shown that one simplified view of planetary gear system. Here in the actual planetary gear system, uh, sun gear is there. Here you are having sun gear. This one is the sun gear, and pinion gears, these are the pinion gears, and these are the gears, and ring gear. This one is the ring gear. You may observe here teeth of the ring gear. See here, these are the teeth of the ring gear. So we can say that this bigger ring you are having with the teeth is known as what it is, the ring gear. Okay, so this is about just uh, this is about the diagram of planetary gear system. Simplified view also you have, and the actual diagram of planetary gear system is also you have in this particular diagram. Now moving towards how it works, and I will explain now about the planetary gear system. Okay, now the overdrive and automatic transmission makes use of planetary gear system, which consists of an outer ring gear called annulus, already as shown, or internal gear. So internal gear means what, teeth are there inside the gear. So this is like, you may observe here in this particular diagram. I will show you. Okay. Here you may observe, so this teeth are there inside the gear, so that's why teeth you may observe here, these are the teeth, okay, inside the gear. So that's why it is known as what it is. That's why it is known as what is outer gear called annulus or internal gear. So its teeth are inside, so that's why it is known as what it is, internal gear. So, and then now second one is the planet pinion. The planet pinion held on the pinion shaft and carrier by the carrier or a cage, and Third one is the sun gear, that also I shown already, sun gear. Okay, that whatever gear you are having here, this one is the sun gear. Okay, this one is the sun gear, and these are the pinion gear. Okay, pinion gear. So likewise we are having the different parts where you are having here in the planetary gear system. Now the working of planetary gear system. Okay, the pinion whatever pinions are revolves around the sun gear, similar to the planets in the solar system. Whatever the solar system you may observe, around the sun all the planets will be revolved or orbiting around the sun. Similarly here also we are having that system, so that's why it is known as what is planetary gear system. Sun gear is there and pinions are revolve around that particular sun gears. Okay, like how we are having planets in the solar system which are revolving around the sun. So likewise here also the pinion gears will be rotates around the sun gear. In this system the planetary gears have bodily motion in addition to the rotation about their own axis. So they are those planetary gears or pinion gears having their own axis around that only. With that only those planetary gears will be rotates. Okay, their axis rotates about axis of sun gear. Okay, axis of sun gear. Okay, different different speed ratios or torque ratios are obtained by making any one part planetary like sun gear, planet gear or cage by inner locking two part with each other. A direct or solid drive is obtained. A direct or a solid drive will be obtained. Okay, the various combinations of gears are explained as follows. Okay, we are having different combinations here, gear combinations that we can I can explain here. The speed increases. Okay, if speed increases, so that time what type of gear combinations are required, that we have here. If we hold a sun gear stationary and turn planet pinion case, the pinion shaft will be carried around the cage cage. As pinions are meshed with sun gear, they rotate their shaft and walk around the stationary sun gear. The planet pinions are also meshed with the ring gear and hence drives it. This ro- rotates the ring gear faster than the planet pinion cage. By using gears of the different size, the ratio between planet pinion cage and ring gear may be altered. As an example, if the ring gear makes one complete revolution, the cage turns only 0.7 revolutions. The planet pinion drives the ring gear much faster than the cage, and the gear ratio between these two may be 1 is to 0.7, as the driven member or a ring gear turns faster than the driving member. Planet pinion cage, the system works as a speed increasing mechanism. So likewise speed increasing mechanism will be done by using whatever I already explained here with this particular paragraph. And then now the speed reduction. So how to reduce the speed? By using some other combination of gears here. Assume that sun gear is stationary. Turning of the ring gear will be cause the planet pinion case to turn slowly than the ring gear. Okay, turns to slowly than the ring gear. This is exactly opposite to the previous condition. Whatever it is there in the previous condition, so opposite that only we can do here to get to reduce the speed. Okay, so and the system function as speed reduction mechanism. The driving member or a ring gear drives the driven member cage slowly. Okay, likewise we can reduce the speed. Now speed increase. Previous one, first one is speed increase. One more combination we are having to increase the speed. Hold the ping gear stationary and turn the planet pinion cage to the drive sun gear. The sun gear is forced to rotate faster than the case. That is, the driven member or sun gear, whatever you are having here, sun gear. So this one is the sun gear. Already I shown that sun gear turns faster than the driving members. So these are the driving members. Sun gear will be turn faster than the driving members or a planet pinion cage, and the system becomes speed increasing mechanism. So likewise also we can increase the speed of the vehicle. This combination also can use to increase the speed. So one more combination we have here to reduce the speed reduction. One more, that is fourth combination we are having here. How to reduce the speed with the one more combination. If we turn the sun gear to drive planet pinions on their shaft by keeping ring gear stationary, the pinion walk around the ring gear as they are in mesh with it. The planet pinion case is also carried around and hence rotate at lesser speed than the sun gear speed. So planet gears will be rotate with a lesser speed than the sun gear planet. The sun gear becomes driving member and turns planet pinion case slowly, and the speed will be reduced. So the reduction speed reduction will be we will obtain speed reduction by using this type of mechanism. Now one more gear arrangement for reverse. Okay, for the reverse we are having one more combination, so that I will explain now. Keep the planet pinion case stationary. Okay, planet pinion case stationary, whatever you are having here, planet pinion case. Okay, so this one you need to keep it stationary and turn the ring gear. Okay, ring gear you are having here, you need to turn this one ring gear. The planet pinion becomes idler and turns the ring gear in the opposite direction. Okay, now planet pinions become idler and turns. These are the planet pinion gears. It will turns the sun gear or a sun gear in the opposite direction to the rotation of the ring gear. So whatever you are having here, ring gear, so opposite to that sun gear will be rotate, so that we get reverse rotation system, and the sun gear is turning faster than the ring gear. Ring gear is the driving member and the sun gear takes the drive and turns in the opposite direction to the ring gear. Okay, likewise you get the reverse vehicle. You can move in the reverse. We can take the reverse. Okay, now one more mechanism we are having for the reverse. Okay, so that is or a mechanism, or we can say that the arrangement of gears for the reverse. Hold the cage stationary, turn the sun gear to drive whatever case you are having here. So this case should be stationary now, and turn the sun gear to drive ring gear in the reverse direction but slower than the sun gear. Okay, so likewise we can get the reverse by using one more mechanism or one more arrangement of gear. Now the seventh one more last arrangement, that is the uh, direct drive. Direct drive. The, the input and output shaft turns at the same speed by locking any two or three members in the planetary gear system. The whole is locked. There is no speed change through reduction gear system. A direct ratio of 1 is to 1 is obtained. However, if no member is held stationary and no two members are locked together, then the system will not transmit power. The input shaft will turn without driving the output shaft. So likewise, direct drive will get by this combination of gears, whatever we are having there in the planetary gear system. You are having here now one table. You are having for the condition 1 2 3 4 5 and 6 ring gear. Okay, you may observe above table shows various possible condition in the planetary system. Okay, now overdrive operation. For the overdrive operation, we are having one diagram figure, that is overdrive fluid coupling or a fluid flywheel. Overdrive operation. In the overdrive, the overturning clutch is splined to the transmission output shaft in the back of splined pinion carrier. The ring gear is attached to the overdrive output shaft. You may observe here different parts of the overdrive fluid coupling or a fluid flywheel. Diagram is not clear. Just a minute. Okay. In the overdrive, overturn clutch is splined to the transmission output shaft in the back of splined pinion carrier. The ring gear is attached to the over gear output shaft and three planet pinions mounted on the cage, which is splined to the transmission main shaft. The sun gear may be allowed to turn or may be locked to keep it stationary. The output shaft overdrive the transmission main shaft when the sun gear is locked. When the transmission main shaft and overdrive output shaft are turning at the same speed, or when transmission shaft turning faster than the internal gear or overdrive ALP shaft, the sun gear is free. The overturning clutch or a free wheel mechanism will drive the internal gear or a overdrive output shaft. The power directly goes to the clutch cam, which is splined to the transmission main shaft. The clutch cam transmits power through the roller to the outer race, which is attached to the output shaft. When sun gear is stopped, the planetary action will be drive the internal gear faster than the cage. The clutch hub and overrunning clutch will remain disengaged. So likewise, you can get overdrive operation by the again the different combination of gear. Now the fluid coupling and or we can say that fluid flywheel. It is a device why we can use the fluid coupling. Okay, fluid coupling diagram you are having here. This is the fluid coupling diagram. Okay, so different parts of the fluid coupling diagram. Here is the driving rotor, driven rotor. Driving rotor, you are having driven rotor, and crankshaft, you are having transmission shaft and flywheel. Okay, so this is what it is, diagram for the fluid flywheel. Okay, this is a why we need to use this one in the vehicle. Okay, that I will explain now. So now it is a device for transmitting rotation between shaft by means of the acceleration deceleration of the hydraulic fluid. By acceleration and deceleration, we can transmit rotation between shaft. So structurally, a fluid coupling consists of impeller on the input or driving shaft, and runner on the output driven shaft. The two contains the fluids. Impeller and runner are bladed rotors. The impeller acting as a pump and the runner reacting as a turbine. Basically, the impeller accelerates the fluid from near to its axis, at which the tangential component of the absolute velocity is low to near its periphery, at which the tangential component of the absolute velocity is high. This increase the velocity represents an increase in kinetic energy. The fluid mass emerges at high velocity from the impeller, impinges on the runner blades, gives up its energy, and levels the running at low velocity. Low velocity. Okay, now construction and working of fluid coupling as follows. So principle of flywheel. This is the diagram for principle of fluid flywheel. Now construction, so how it works and what how it is constructed, that is fluid coupling, I will explain now. An automobile fluid coupling consists of a split housing which is rotated by engine crankshaft. Inside the housing is an driven member is called runner, and driven member is connected by the shaft to the gearbox. The driving member is mounted on the crankshaft and it is called impeller. The driving or input, driven or output members are very close to their ends, facing each other and enclosed in housing so that they can turn without touching each other. The liquid or oil is filled in a housing. The flywheel housing is divided into number of cells by means of radial vanes. These cells corresponding to the similar openings in its driven member. Okay. When the crankshaft runs, the driving member or impeller also rotates. The fluid flows outward due to the centrifugal force and circulates from the flywheel or driven member. Now the fluid tends to rotate the driven member because the fluid is also carried out round by the driving member. The fluid is also carried out round by the driving member. The fluid is also carried out, so the fluid tends to rotate the driven member. This Thus, the torque is transmitted from crankshaft to the gearbox shaft. The liquid coupling is not suited for use with an ordinary gearbox. This is generally used in a conjunction with epicyclical gears to provide a semi or fully automated gearbox. So likewise, we are having the working principle of the fluid flywheel. Now torque converter. About the torque converter, and then I will explain now this one, torque converter. Where is that? Torque converter. A torque converter is generally a type of fluid coupling that is used to transfer rotating power from prime mover such as internal combustion engine or electric motor to the rotating driven load. The torque converter normally takes the place of the mechanical clutch in the vehicle with automatic transmission, allowing the load to be separated from the power source. It is usually located between engines, flex plate, and transmission. The key characteristics of the torque converter is its ability to multiply torque when there is a substantial difference between input and output rotational speed, thus providing the uh, equivalent of the reduction gear. Some of these devices are also equipped with a temporary locking mechanism which rigidly binds the engine to the transmission when their speed are nearly equal. To avoid slippage and the a resulting toss of efficiency, torque converter are sealed in its their inert rarely see the type of day, and when they do, they are still pretty hard to figure out. Imagine you have two fans facing each other. So two fans, whatever, for example, two table fans, for example, if you consider, which are facing each other, turn one fan on and it will blow air over the blades of the second fan, causing it to spin. But if you hold the second fan still, the first fan will keep right on spinning. That's exactly how the torque converter works. One fan called impeller is connected to the engine. The other fan, the turbine, is connected to the transmission input shaft. Unless the transmission is in neutral or park, any motion of the turbine will move the vehicle. Instead of using air, the torque converter uses liquid medium which cannot compressed oil, otherwise known as transmission fluid. Automatic transmission cars used to use a torque converter. This article will be discuss why automatic transmission cars need a torque converter and how the torque converter works. The torque converter is an automatic transmission, serves the same purpose as the clutch in the manual transmission. The engine needs to be connected to the rear wheels so the vehicle will move, and disconnected so that engine can continue to run when the vehicle is stopped. One way to do this okay, to do this to do this is to use a device that physically connects and disconnect the engine and transmission. A clutch another method is to use some type of the fluid coupling such as torque converter, which is located between engine and transmission. There are three components inside the very strong housing of the torque converter which works together to transmit power to the transmission. First one, the turbine and stator. Pump, turbine and stator. Okay, one by one we'll see those. The pump inside the torque converter is a type of centrifugal pump. Centrifugal pump, you observe already, you know about the centrifugal pump, which is there in our fluid mechanics lab. So same type of pump we are having here. We are in the torque converter. As it spins, the fluid is flung to the outside, much as spin cycle of the washing machine uh, flings waters and cloths to the outside of the wash tub. As fluid is flung to the outside, the vacuum is created that draws more fluid in at the center. The fluid then enters the blades of the turbine, which is connected to the transmission. The turbine causes transmission to the spin, which basically moves your car. The blades of the turbine are curved so that the fluid which enters the turbine from outside has to change direction before it exits the center of the turbine. It is this directional change that causes the turbine spin. As the turbine causes the fluid to change direction, the fluid causes the turbine to spin. The fluid exits the turbine moving opposite the direction that pump are turning. If the fluid were allowed to hit the pump, it would slow the engine down, wasting power. This is why a torque converter has stator. Stator resides in the very center of the torque converter. Its job is to redirect the fluid returning from the turbine before it hits the pump again. This dramatically increases the efficiency of the torque converter. Okay, cut section of torque converter you may observe here, whatever I already explained. Okay, driven, you are having driving part is there here, driven part, driving part. Okay, split guide, you are having split guide here. Okay, so likewise the cut section of torque converter diagram. In brief in brief, the torque converter is a type of fluid coupling which allows the engine to spin somewhat independently of the transmission. It is responsible for pressurizing the automatic transmission fluid. Pressurization the supplies the force necessary to shift transmission gear. A one dysfunctional torque converter can prevent transmission fluid from being properly pressurized, which is in turn negatively impacts transmission gear functions and operation. A systematic checkup by a professional is the best way to isolate the cause of operating problems and recommended the most effective solutions. If properly turned, this complex drive can have a tremendous impact on your vehicle's performance, economy, and durability, and that and turn your automatic into powerhouse. Powerhouse. Okay. Now, so operation. operation of torque converter. So how it operates, okay, that will I will explain now. Okay, first one, torque converter has three stages of operation. Here the torque converter multiplication by using stator. One diagram you may observe here. So this one is the diagram. This one is the diagram. Torque multiplication by using stator. Okay. Now the operation of torque converter. Stall. Okay. First one is the first part is stall. The prime, what is the meaning of stall, that will I will explain now. Okay, the prime mover is applying power to the impeller but the turbine cannot rotate. For example, in automobile, this stage of the operation would occur when the driver has placed the transmission in gear but is preventing the vehicle from moving by continuing to apply the brake. At stall, the torque converter can produce maximum torque. Multiplication of the sufficient input power is applied. The stall phase actually lasts for the brief provide when the load initially starts to move, as there will be a very large difference between pump and turbine speed. Acceleration. The load is accelerating, but there still a relatively large difference between impeller and torque speed. Under this condition, the converter will produce torque multiplication that is less than what could be achieved under stall conditions. The amount of multiplication will depend upon the actual difference between pump and the turbine speed, as well as various other design factor. Now coupling. The turbine has reached approximately 90% of the speed of the impeller. Torque multiplication has essentially ceased, and the torque converter is behaving in a manner similar to the simple fluid coupling. In modern automobile applications, it is usually at this stage of operation where the lockup clutch is applied, a procedure that tends to tends to improve fuel efficiency. The key to torque converter ability to multiply torque lies in the stator. In the classic fluid coupling design, periods of the high slippage cause the fluid flow returning from the turbine to the impeller to oppose the direction of impeller rotation, leading to a significant loss of the efficiency and the generation of considerable waste heat. Under the same condition, in torque converter, the returning fluid will be redirected by the stator so that it aids the rotation of the impeller instead of impelling it. The result is that much of the energy in the returning fluid is recovered, added to the mass of the fluid being directed to the turbine, producing an increase in output torque. Since the returning fluid is initially traveling in the direction opposite to the impeller rotation, the stator will likewise the attempt to the count, counter rotate, as it forces the fluid to change direction, an effect that prevented by the one-way stator clutch. Unlike readily straight blades used in the plain fluid coupling, torque converter turbine and stator use angled and curved blades. The blade shape of the stator is what alter the path of the fluid, forcing it to coincide with impeller rotation. The matching curve of the turbine blades helps to correctly direct the returning fluid to the stator so that the latter can do this job. The shape of the blades is important as minor vibrations can result significant changes to the converter performance. Okay, torque converter, one more diagram you are having here, you may observe. So impeller, this is the impeller, and the turbine you are having, this is the turbine. Okay, force wheel, force wheel, and outer shaft you are having here. This is the outer shaft. This is the outer shaft. Okay, and now here input shaft. This one is the input shaft. So likewise, torque converter will work. So remaining part, that is epicyclic gearbox, that one I will discuss in the next video. Principle of automatic transmission, I will discuss that one. These two part remains here in this model. I will discuss this one in the next video. Okay, thank you.